All right, video problems, part 2. Finish off the second page. We're going to verify the mean value theorem for the function x squared from 0 to 1. Again, we're going to look for a tangent slope that is parallel to the secant slope between those 2 points right there. Verifying the mean value theorem, first of all, we have to say, is this a continuous function? And we say, yes, it's polynomial. Is this function differentiable on the open interval from 0 to 1? And again, we say yes. Derivative is a polynomial. So we know that we're good to go. We need to calculate the slope from 0 to 1. So when I plug 0 into my function, I have the point 0, 0. And when I plug 1 into my function, I have the point 1, 1. And I need to set the slope of that equal to the derivative of x squared. So I take 2x, the derivative, and set it equal to my secant, which is 1 minus 0 over 1 minus 0. When does 2x equal 1? And that happens at x equals 1/2. X equals 1/2 is the value where the tangent and the secant have the same slope. All right, how about for number 3? What does the mean value theorem say about this function? Again, we need to answer these 2 questions, continuous and differentiable. Is this function continuous? And we look over here and we notice that it's a fraction, and we always think that a fraction is discontinuous at the denominator equal to 0, which happens when x minus 2 is equal to 0, which happens at 2. And you notice that that number 2 falls directly between 1 and 3. Is this function continuous on the closed interval from 1 to 3? And the answer is no. The domain is all real numbers except 2, therefore discontinuous. What does that mean? That means that the mean value theorem just does not apply, and you don't go any further. We're all done with that problem. For question 4, what does the mean value theorem say about this function? Again, we start out at the beginning. Is this function continuous? And we look here. That function is always continuous. The domain is all real numbers. So we answer yes. Is this function differentiable from the open interval of -1 to the square root of 8? Well, sometimes to answer this question, you actually have to take the derivative. So in this case, we're going to take the derivative of this. F prime of x is equal to 2/3 x to the -1/3 plus 0. Write that as a fraction. That's really 2 over 3 x to the 1/3. I notice now that I have a denominator, right? And I know that that denominator cannot equal 0. That denominator equals 0 is at 0. And is 0 in the middle of this interval right here? The answer is yes. The domain of the derivative is all real numbers except not 0. Therefore, this function is not differentiable from 0 to the square root of 8. Therefore, again, the mean value theorem does not apply to this function, and we just don't do any more work. The problem is all over. All right, for question 5, it says, suppose that f of 0 is equal to -3, and f prime of x is less than or equal to 5 for all all values of x, how large can f of 2 possibly be? If you look at the question and you're not quite sure how to approach it, one indicator that it's in the mean value theorem section is that we maybe are going to use the mean value theorem, so let's think about how to use that. We do have this one point right here, and that one point is 0, -3. And then they talk about this other point over here, f of 2. And we don't know what that is. We do know that the x value is 2, but we don't know what f of 2 is. And they actually say, how big can this be? It does say here that the derivative is always less than or equal to 5. So that means the slope of this secant line will never also be greater than 5. So if I look here and I take my secant slope, f of 2 minus -3, all over 2 minus 0. Remember, change in y over change in x. These are my y's. These are my x's. I say that that right there has to always be less than or equal to 5 because that says that my slope is never more than 5. We can solve this problem right here. So we have subtracting a -3 is adding 3. We have 2 minus 0 is 2. We can multiply both sides times 2, and then we have f of 2 plus 3 is less than or equal to 10. Subtract 3, and I have f of 2 will always be less than or equal to 7. How large can f of 2 be? The largest that it can be is 7. Applying the mean value theorem. The last question we have here is an application question. It says that the rate at which water flows out of a pipe in gallons per hour is given by a differentiable function, r, of time t. The table shows that the rate is measured every 3 hours for a 24-hour period. Is there some time between 0 and 24 where the derivative is equal to 0? Again, this applies the mean value theorem because this function is differentiable and the water continues to flow out, so it is a continuous function. So basically we need to find out, is there any time between 0 and 24 where the derivative is equal to 0? Again, secant slope equal to the tangent slope. And in this case, they're asking about 0 and 24. And what do you notice about those two values? If you notice, the y values are both the same. If you're going to find a slope between those, you're going to do 9.6 minus 9.6 over 24 minus 0. My secant slope is equal to 0. Therefore, I know that the tangent slope, which is again your instantaneous slope, or rate of change, I guess, will sometime also be 0 by applying the mean value theorem. Go ahead and take out your homework, work on the questions that you have. Then after you're done, go to those ACT questions and work on those. That is all the homework that you have, and I will see you on Wednesday.